Hello, let's continue our advanced Sudoku series with Garam Masalas by Philip Newman. So this is puzzle number 3 of chapter 4 of the Sudokult Gospel document, which you can find in the description. And as always, I know what technique I'm looking for, but not where it is exactly. Someone asked how I knew that. Well, at the bottom of the document, you can reveal if you want what technique they're intending. So I do that and I make sure I understand what it is. But also in addition to that, I do remember this puzzle specifically was covered in the Sudoku discussion videos that I did with Philip 2 years ago. Do I remember specifically this puzzle? No, but I obviously have encountered it before because we did discuss this puzzle in those episodes, but I haven't rewatched those episodes recently. So yeah, this will be like super quasi live solve. We'll see how I do. But yeah, there's a link in the description if you want to try the puzzle yourself first, and I'm going to get started right now. All right, I'm going to get as much info as I can. Like I'm noticing these ones look over, so we can place a 1 here. What else do we have over here? We have 2 2s looking in, so 2s in one of these two. 1s, 2s, 5, 4. I'm noticing these 2 2s look down, putting a 2 over here. Okay, how about here? We have 2 6s looking in, so 6. Oh, and 6 is placed actually, because the 6 looks up. That puts a 6 over here. What else can we do? 5, 6, 5, 4. Let's look over here. 4, 5, 6, 7. 3, 4, 5, 6, 7, 8, 9. So no repeats. These 6s do look in though, so that puts a 6 here, which puts a 6 in one of these two. Those 6s look up, putting a 6 in here somewhere. What else is going on? Okay, let's look vertically a bit. 3s, 4s. Okay, 4, not good enough. Okay, this 8 looks in, putting an 8 in one of these two. Oh my gosh, here we go. 8 in one of these two. Points up, no. 5s. 8s. Okay. Did I miss anything? Maybe. It feels like, okay, I got 5s looking into here. So 5s in one of these two. And I've also got 2s looking into here. So this is a hidden 2-5 pair. That leaves what? 1, 3, and 9 here. Let's see, this 5 looks up, this 5 looks in. It's not quite. 6 looks up. Okay, what? Are 6s doing anything? We got 6s here, here. They're like here and here. Weird. I don't see anything to do with that. Okay. 5s, no. 8s, no. 7s, no. Okay, well, I think that might be all I get. Oh, this 4 looks in. Oh, and this 4 looks up. Okay. How did I miss that so long? That places a 4 here. Now this 6 looks up, putting a 6 in one of these two. That's not 6. It places this 6. This also isn't 6. So the 6 gets placed there. And wow, we suddenly have a bunch of 6s. Okay, so we're just down to this rectangle of 6s. There was something with 5s, right? Yeah, 5s look in. They join the 2 now because the 6 used up one of the spots for it. That's a 2-5 pair as well. Now this 3 looks up, putting a 3 over here. I'm going to pencil some of these that are down to 4 digits. We have 6, looks like it's 7, 8, 9 here. Over here, we have the 3 here, and then also 7, 8, 9. These 8s point up. It's not 7, 9. Anything else of note? Where else did I place 6s? Or is that helpful? This 1 looks down, so 1's in one of these two. Nope. This middle digit is down to Yeah, down to 3 digits. It's 2, 3, not 3, 2, 4, and 5. Okay. Almost matches this one. Let's see. 5's in 2 places in this column. All right, I'm not sure if I'm going to find much else going on here. 4 is in one of these two. Oh, no, 4 is placed. After I say that, I place a 4. Okay, because I missed that all these 4s look in. So what does that do? It puts a 4 down here. This row is down to 5, 7, 8, 9, and the 5's up here. This is 3, 7, 8, 9. This is 3, 6, 7, 8, 9, not 6. So these are 3, 7, 8, 9. I think I'm penciling too much here, but 1, 3. Okay. I'm not sure if we'll find much else of use right now from normal scanning. Okay, so now let's look for what we're looking for. Now, just based on where these givens are, right? They seem to like go down diagonals. It's almost like they are checkerboarded. So I'm suspecting a checkerboard set here. Now, usually with checkerboard set specifically, so if you see something like this, right, where it's like literally only on, it's like only on what the black or red squares would be in checkers, right? It's literally checkerboarded in our givens. What we want to look for is how to capture the same sets of digits into different checkerboards. Now, sometimes it's odds versus evens, things like that. But okay, so you're generally going to do an imbalanced set as well. So if I take these columns, does that look promising? I think it does, because we've got 3, 4, 5 here, 7, 9. This 4 is going to go away, though. Okay, so let's just make this green. And then you can kind of see how you're going to peek through here with 4 different rows and get rid of a lot of the empty greens. So that's purple. So we can get rid of any cells that are green and purple. And so what we've done is we've made an imbalanced set here. So we started with 4 rows and first 5 columns. So green contains purple plus an extra 1 to 9. 1 each of 1 to 9. Now, okay, so what now we want to do is an accounting of the digits. Okay, so we have duplicate 6s here, so we can remove that. Any other duplicates? So 3, 5, 7, 9. Okay, I got another duplicate 6 here. In fact, this 6 here is accounted for. Oh, sorry. Is it accounted for? Yeah. So this 6 and this 6 go away. Interesting. Shouldn't. Oh, okay. Because purple has an invisible 6 in it, right? You can kind of think about that as purple's got needs an extra. Sorry. Green has an extra 1 to 9 in addition to what's in purple. And that's what this 6 is. That's an extra 6 in green. So we got to be careful about stuff like that. But all right, so let's account for these again. So we know we've got. Does this 4 cancel with anything? The 4 cancels. I suspected it would. All right, so let's look again. Sorry about this. Green's got 2, 3, 5, 7, 9. 2, 3, 5, 7, 9. So what are the digits green doesn't have? They are. I mean, obviously they can be in the blanks, right? But the ones we don't know about are 1, 4, 6, and 8. So it's almost evens versus odds, but the 1s and 2s were swapped. So we've got 2, 3, 5, 7, 9 versus 1, 4, 7, 8. So 1, 4, 6, 8. The 6s we don't even have to worry about because we've accounted for them. So really 1, 4, 8. Now, if you look at purple, we've got the 1 and the 8 here. The 4 is okay. So the 4 is gone. I think we erased the 4s that matched up, so that makes sense. So let's think about purple then. Let's think about purple into green. We need 2 1s, 2 8s, and a singular 4 in green. We also need a 6 in green. Let's not forget about our invisible 6. So we do want to account for that. So we need 2 1s, 1 4, 2 or 1 6, and 2 8s. So that's 7 digits that we need in green. Now, where can they go? We can have 1 8 in these greens. So that's 1. This green can have, so that's how many digits today? Oh my gosh, I forgot. That's 7 digits, right? It was 2, 4. Wait, why was it at 6? Was it 6 digits? Yeah, I need 2 1s, 2 8s, and I need a singular 4 and 6. So, and notice that none of my green digits otherwise are those digits. In fact, let's do something. Let's highlight. Actually, can I do that? I'm not sure I can do that. Never mind about what I was going to say, like highlight the ones that can't be, but like I don't know how I'd account for this, so we're going to have to count it differently. But I think it's 6 digits we need, right? We need 2 1s, 2 8s, a 4, and a 6 into green. This is 1, 2, 3, 4. 5, 6, 7, 8. So we have 2 extra. But there is a 4 in this, but let's see. Maybe we need to count for this a little bit more specifically. This box can take an 8, but nothing else. Right? It can't take the 6. It can't take it. So let's say this 8 ends up in red. Let's account for it that way. So the reds are the same, and then the reds can't be used for anything else. They're just going to have the 8, because 3, 7, and 9 otherwise go in here. And those aren't in purple. Those don't need to be accounted for in purple. So that's one of our 8s accounted for. Down here, we can't use the 4 or the 8. So the extra 4 and the extra 8 can't go down here. So the best we can do is the 1 and the 6. And we are going to have the 6, but I think we're going to need a 1 in these cells. So that's kind of our first conclusion, is that these cells need a 1 in them. Because if they didn't have a 1 in them, then... Well, no, so do they need a 1 in them? Okay, but we're seeing what they can have first. We don't know if that's equal yet. I'm getting ahead of myself, I think. And it might not even be right. So, okay, so what we're going to do is we're going to say we can account for this 1, and we can account for the invisible 6 in these red cells, but we can't use the red cells otherwise. So I have accounted for 1, 2... Sorry, not that one. I've accounted for 1, 2, 3 in here, right? I can only put the 1 and the invisible 6 in here. I can't put the 4 or the 8 in here, because there's already a 4 and 8 in the box. So that's 3. And then 4, 5, 6. That's it. Okay, so these cells have to be the other unaccounted for of 1, 4, 6, 8. And we know they're not 6, so just 1, 4, 8. So these are from 1, 4, 8. Now, do they have to be a 1, 4, 8 triple? Let's see. So I counted for 1, 8 up here. I could account for a 1 and a 6 down here. So I need the extra 1, I need the extra 8, and I need the extra 4. And they have to go here. So this is a 1, 4, 8 triple. I don't think that actually helps me, but I think it's good to remember that this is a 1, 4, 8 triple. Now we need to reverse that and go back into purple. Can we go back into purple somehow? I'm not sure that we can. Well, okay, what we can say is we can't put any more 1, 4, 8s into purple. So any 1, 4, 6, 8s in purple, we can remove. Now, none of them can be 6 anyway. So 1, 4s and 8s can remove. So these can't be 8. That sounds important. 8 ends up in one of these two. And then these are from basically the green digits, 2, 3, 5, 7, 9. So we can clean that up a bit. That's a lot, but also I do have to put a 1 somewhere in here. These greens need to use one of the 1s. Okay, and I think that's the conclusion. So is this enough to solve the puzzle is kind of the question. I eliminated this 8. And I eliminated things from these otherwise empty purples. I eliminated 1, 4, and 8 from them. So who cares about 1s, 4s, and 8s enough to worry about that? I guess these can't be from 1 or 6. We know that from our corner marks. So maybe we should pencil these. So they can't be 1. 2 could go there. They could be from 3. Well, they can't be 3, apparently. Okay. Can't be 4. Could be from 5. Can't be 6. 7. Can't be 8. 9. Okay. They are limited. So just to review, this is a 1, 4, 8. So I've got, in purple, I've got, did I account for this 2, 5 in purple? This whole time I've been ignoring that 2, 5, but actually we can just cancel those. Okay. So in purple, I've got the 1 and the 8 known. And so I need, and because it's an imbalanced set, I also need an extra 1 to 9 in green. So green's going to need 2 1s, 2 8s, a single 4, and a single 6 that aren't accounted for in any of the given cells. And then we found that these could only take one of the 8s. This could take 1 1 and 1 6, but not another 4 8. So that counts for 2 of our digits. And then 2, 4, 5. Right, I needed a 6 as well, right? So hold on. 2, 4, 5, 6. I need 6 digits. How did I do this? So 1, 2, 3, 4, 5, 6. Yeah, the 1 and the 6 count as this. Okay. Yeah, and if we ignore the 6 entirely, because we know the 6 goes up here, then I only need 5 digits because I need 2 1s, 2 8s, and a 4, which is 5 digits. So I need 2 1s, 2 8s, and a 4. This is one of the 8s, or this can be one of the 8s. This can be one of the 1s. But even if I do that, I still only have 3 left. So that is 5, and that they have to be from 1, 4, 8. Okay, got it. Now, if we reverse that on its head, that means that the remaining green cells must be, so the ones that aren't the, yeah, I guess that's just going to happen. The ones that aren't the 1 6 in here have to be from the remaining the 2 3 5 7 9, but we know that. Okay, so I'm not sure there's anything else to get from this set. It was good to review it though, just to make sure I got it right. We know one of these is 8, but that's true from Sudoku. Okay, I think I'm going to get rid of these red markings. What else can I do here? I feel like this being a triple feels important, but maybe there's just something simpler. This 7, 9. Removing 8 from here, maybe that was helpful. Is it 8 in this column, perhaps? This can be 8, though. So it's not 8 in the column. 8 in the row? It's in 2 places? I removed some digits from these purples, so let's think about that. I removed the possibility of them being 1, 4, or 8. Oh, this can't be 4 then. This purple's not allowed to be 4, and that gives us a 2, 5 pair. That's what I missed. So that's not a 2. I'm going to highlight these in yellow just to remind myself that that is a triple. Yellow doesn't look good. Let's do red. Let's do blue. Blue to remind myself it's a triple. All right. Maybe this column's helpful. I'm not sure if that's true. Well, I've got 2, 5 here. So with this 2, 5 pair, what's that do to these cells? So they can't be 1, 2. So we've got 3, 4, 6, 7, 8, 9 left. This bottom one cleans up quite nicely. 4, 8. Oh, what about this? um, can't be 1. Can't be 2, 3, 4. Can't be 3 or 4. Can't be 5, 6. So this is from, oh, can't be 7, 9 either. So this is a -8. Okay, and that's a 4. That's a 4. Okay, this is not 4, 8. So I've got this 3, 7, 9 triple now. 2, 5. So I got this 8 and 4. How's that help? So the 8s look into here. Putting an 8 in one of these two. I've got so many markings going on here. Making it harder to scan the puzzle. What about the rest of this box? This is 1, 2, 5. So that's a triple. So these can't be 2. Important. So that's a 2. 1, 2, 5. This isn't 5 either. We have 3. This isn't 5 either. We have 3, 7, 9 left. Okay, so I found a 2, 5 pair in purple. We can remove that from green. Just trying to keep up with my set here. If I'm going to leave it colored, I might as well make it useful. You know what I can do is I can say that this 8 is part of this 8, and then I can also potentially, can I remove a 3? Oh, I don't know if it's 3, 7, or 9 though. That's the problem. So I wouldn't know what these end up being. Okay, that's not helpful then. Never mind. This column is 1, 2, 7, 8, 9. That's not helpful. What about this column? Because this we removed some digits from it. We need 2, 3. Okay, that's promising. 5. Well, that's very promising. 7 and 9 here. Oh, this is a naked 7. So let's just double check. It sees 1, 2, 3, 4. It sees 5 in the box, 6 in the box. Where does it? Oh, it doesn't see 7. It sees 8 and 9. Okay. So that's a 7. That's not 7. Looks like naked singles are key here. 2, 3, 5, 9. Not much to do with that. Do I do this box? Do I do this row? Maybe this row. So this row needs 1. It has 2, 3, 4. It needs 5, 6, and it needs 8. Okay. 1, 8 pair. So these can't be the ones. So this is the 6. This is the 5. The 1 does end up down here. So 5 and 6 in green. I'm not sure I can do much with that. That places the 6 and the 8, though. These are not 8s. So now the 8 is definitely down here. 1, 8 pair. This is 2, 3, 9. These are 1, 2, 3, 9. Neither of them are 2. So the 2's down here. These are 1, 3, 9. It's not a 3. It feels close. So, one of these is a 4 because of this 1, 4, 8 triple. So this can't be 4 anymore. It couldn't have been 4 anyway. We didn't learn anything. But what can this be? 3, 5, 7, 9? Not a 7, not a 5. So 3 and 9 only. That's a 3, 9 pair. So this is a 1. That means this has to be the 1. That's an 8. These aren't 1s. We have a 4, 8 pair now. And I'm starting to think I don't need my colors at all anymore. But I did find a 1, so let's get rid of those. Boom. 4, 8 pair. Again, not sure what to do with that. These aren't 1s. Oh, right. So 4, 8 pair, I can get rid of the 8. The problem is the 4 is in that hidden extra 1 to 9. Do I have a full 1 to 9 I can remove? I'm not sure I do. Because I don't know what these end up being, and I don't want to remove the wrong one. It's not really important at this point. I just think it's fun. All right, so these aren't 7, 9 because of the 7, 9 pair. So this is 3 and 8. That's not a 3. I have a 3 now that I can remove. Boop. Okay. It would be kind of cool to see the extra 1 to 9 just appear in green when we're done. So let's just leave that colored anyway. What's our next step? This is pretty much collapsing at this point. I just need to find the right things to do. 3, 9, 2, 5. 7's in one of these two. Sure. What's like the juiciest thing to pencil right now? Maybe this column, 1, 3, 7, 9. Ooh, that was not juicy at all. This column, I need 1. I've got 2, 3. I need 4. I've got a 5, 6. I need 7, 8, 9. Cleans up a bit, but not nicely. 3, 9 pair, 2, 5 pair. 8 in this column. No, that doesn't help. 8 in this box. No. I don't need these blue anymore. We know it's a 4, 8 pair. Wow, the Sudoku at the end of this has not been easy. I mean, it's been basics, but I don't know. I've been having a tough time. 1, 2, 7, 8, 9. That's not helpful. Gosh, I must be just missing something dumb. One's down there, 2's down there. 2's line up, that doesn't help. 3, 9, 3, 7. 9. Oh, this is a 3, 5 in this column. Darn it. So that's a 5. That's a 2. That's a 5. That's not a 2. We get the 9 and the 2 here. That's a 3. We get the 1 and the 3. Cool. So now we know where the 1 is. All right. So that's 7. That's 9. That's 5. Let's just finish this. These aren't 3. These aren't 1. I don't know. It's kind of fun to track the set, isn't it? I feel like that's fun. So I know where this 1 is now. Do I have enough for the extra set? 1, 2, 3. If I take the 4 and 8 from that, I can do the 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is my extra 1 to 9. So I can get rid of that now. And now we have a balanced set. These 5s remove. This 8 goes up here along with the... does it go along with the 3? Ooh, actually, I have a 7, 9 pair here in purple. Hold on, how's that work? All right, so I've got 2 7s in green. Interesting. I mean, I'm sure I could just finish the puzzle off. Do I have 1, 2, 3, 4? I have too many. Oh, no. Oh, sorry, there's 3 down here. Okay, we can remove those. So purple has... Yeah, so this decision is based on this decision. That's kind of funny. We know the 8 goes in here, and then we know this 7 is part of this 7, 9. This... oh. Actually, I think this has to be a 7. In fact, it is for the column. Look, it's a 7. That's what was confusing me. Okay. So that's a 7. I don't know. I literally pressed Q as if that would... What goes on with my hands sometimes? So these 7s can go away. And so this has to be a 9 because this is 7, 8, 9. So this has to be 7, 8, 9. It can't include the 3. So we can place the 3 there, and then this is 9 and 8. Nice. Got to use the set instead of basic Sudoku. But now we have the 7, 8, 9s accounted for, and our entire set has been accounted for. All right, that's 2 and 5. That's 8. I mean, it's correct. That's 8, 9, 1, 3, 7, 4. That's 3 and 9. That's 7, 9. Over here we have over here we have 7, 9, and we have 2 and 3. All right, and we're done. Got it correct. So there's that. Cool. So the moral of the story is the set. If you analyze the set a bit further, you can end up having to squeeze it in, even if it doesn't seem like the count is correct. Like we had way too many open cells for the digits we needed to count for. But if we actually count how many can actually go based on the boxes, for example, that really helps. So I'm wondering if there's some way to, I don't know, account for that with like a third set. I don't know. Does that even make sense? Like putting these boxes into a set as well, or like incorporating them into the set in some way, so that you see these givens here. I'm wondering if there's some way to visualize that. I'm not entirely sure. So kind of doing that analysis for you instead of having to sort of count. But anyway, that was neat. It does kind of ring a bell on how we did that in Sudokult discussion. But anyway, I hope you enjoyed this. I know the Sudoku at the end took me a while, but it was fun tracking that set and stuff. Either way, I got the feeling it was mostly singles, and I just wasn't finding them. But there were some nasty hidden singles hiding around there. So yeah, let me know how you did. Let me know if you enjoyed this, and if you did, why not leave a like, subscribe, and a kind comment below.